Alhamdulillah, wassalatu wassalamu ala rasulillah wa ala alihi wa sahbihi wa man wala. I'd like to welcome you all in the continuation of the last part of the proof for the average case analysis of quicksort. Right. So where did we stop in class? As I said, we basically stopped at trying to solve this recurrence, which is basically dn equals dn minus 1 plus 2 times n minus 2 divided by n times n plus 1. So this is dn. And the stopping criteria, d1. What is d1? Well, d1, according to this, is c1 divided by 2. So what is c1? Well, C1 is 0. The number of element comparisons that we carry out to sort an array with one element is basically 0 element comparisons. So since C of 1 is equal to 0, then we know that D of 1 is equal to 0. Okay, we know that D of 1 is equal to 0. So let us now write that down and then go ahead and try to solve. So basically, what is left is just trying to solve this recurrence equation, right? So d of 1 is equal to 0. Okay. So how do we do it? Well, obviously, since it is dn equal dn minus 1 plus something, we are going to use the expansion, right? And expansion, or sometimes it is called the iteration method. So the value of dn is equal to dn minus 1 plus what? Plus 2 times n minus 1 plus 2 times n minus 1 over n times n plus 1. Okay. But how do we do that? Well, the usual way. So this is my dn minus 1 and plus 2 n minus 1 over n times n plus 1. Okay. Right. So now this is dn minus 1. So if we put here n minus 1, what do we get? We get dn minus 2 plus twice n minus 2 times divided by n minus 1 multiplied by n, right? So this is d n minus 2 plus twice n minus 2 divided by n minus 1 multiplied by n. If we do it again, we will get d, okay, whatever we get, and let's put this outside, 2 n minus 2 divided by n minus 1 times n plus twice n minus 1 divided by n times n plus 1, n times n plus 1. Yeah. So now, if I put n minus 2 here, it will be dn minus 3 plus twice n minus 3 divided by n minus 2 multiplied by n minus 1. So dn minus 3 plus twice n minus 3 divided by n minus 2 multiplied by n minus 1. So now you can see the pattern. Okay, now you can see the pattern, and we will continue until we reach what? Until we reach d of 1. لأنه we know that d of 1 is equal to 0, صح? d of 1 is equal to 0. طيب, so if I have d of 1 here, what am I going to have here? Okay, think about it. dn minus 1, 2n minus 1, n times n plus 1. This is 2n minus 2 over n minus 1 times n. This is 2n minus 3 times n minus divided by n minus 2 times n minus 1. طيب, d of 1, yeah, 2 times 1 over 2 multiplied by 3. صح? Plus 2 times 2 over 3 times 4 plus, and we will continue until we reach twice n minus 1 over n times n plus 1. طيب. So this one goes to 0, and I have basically the summation. Sigma, okay, twice. ايش رايكم if we use j, then this will be what? If we use j, obviously it will be j plus 1 times j plus 2, صح? j plus 1 times j plus 2. And j run from where to where? It's very obvious. J runs from 1 to n minus 1. J runs from 1 to n minus 1, which is equal to twice sigma j over j plus 1 times j plus 2. Okay? J plus 1 times j plus 2. Of course, j equals 1 to n minus 1. So now what do I have to do? Now, all that I have to do is I need to evaluate the summation. Okay, I need to evaluate the summation. How do we evaluate the summation? Well, this is a question for you. Inshallah, tomorrow, Thursday, when I come to class, I expect each and every one to answer it. I'm going to do a method now. I want you to tell me what is the name of this method and which course did you take it? Because I'm pretty sure that you have taken it. Okay? So let me show you. So the idea is I'm going to take this fraction and I'm going to break it. Okay? So basically what I need to do is, so I need this fraction j over j plus 1 times j plus 2. I want to write this as constant a divided by j plus 1 plus constant b divided by j plus 2. Okay, and as you can see, the degree of the polynomial here is 1 less than the degree of this polynomial. Okay, fine. So if I want to write this summation as this, we will see that, you know, evaluating it will become simpler. Okay, evaluating it becomes simpler. And this is maybe the fourth or the fifth trick in trying to, you know, memorize how to generate the proof for the average case behavior of the quicksort. Fine. So how do we get till A will B? Well, just add them up. So this is what you have learned in maybe 8th or 9th grade. So we have j plus 1 multiplied by j plus 2. And then, of course, A is multiplied by j plus 1 plus B, A multiplied by j plus 1, لا, A multiplied by j plus 2, right? A multiplied by j plus 2 plus B times j plus 1. So this basically is exactly the same as this. And now, if I want to unify the coefficients of j and basically the constant, this will be equal to j multiplied by a plus b plus, what do we have? So j multiplied by a plus j multiplied by b. This is j multiplied by a plus b. And then we have 2a plus 1b. 2a, let me try to make it. So 2a plus b, okay? 2a plus b, of course, divided by the same denominator. 2a plus b divided by the same denominator. We're done. So now, this numerator, j times a plus b plus 2a plus b is equal to j. So the coefficient of j here is 1. The coefficient of j here is a plus b. So a plus b should be equal to 1. Fine. The constant here is j plus what? J plus 0. So the constant here is 0. The constant here is what? 2a plus b. So I have 2a plus b is equal to 0. So I need to solve these two equations. Okay. So let us solve these two equations. So I have a plus b is equal to 1 and 2a plus b is equal to 0. So let us subtract. So if I call this star and I call this double star, so double star minus a star is equivalent to what? Well, it's the same as saying 2a minus a. So this is a. 2a minus a is a. b minus b is 0. 0 minus 1 is minus 1. So a is equal to minus 1. And therefore, this implies that b is going to be equal to what? To 1 minus minus 1. So plus 1, which is equal to 2. And therefore, now the summations are, so now we can write the summation. J over j plus 1 times j plus 2. So now j over j plus 1 times j plus 2 is equal to what? Is equal to, well, let's put b first, so because it is positive. So it is equal to b divided by j plus 2. So 2 divided by j plus 2 minus 1 divided by j plus 1. Okay, and since that's the case, so the summation, sigma j over j plus 1 times j plus 2 from j equal 1 to n minus 1, this is equal to sigma, and let me do this in one step. So this is sigma 2 over j plus 2 from j equal 1 to n minus 1 minus sigma 1 over j plus 1 from j equal 1 to n minus 1. I just distributed the summation over 2 over j plus 2 minus 1 over j plus 1 because summation is commutative. A plus b is equal to b plus a. So I can rearrange the terms, and of course it's also associative. So I can rearrange the terms and I can put them like this. Why did I do that? Well, now you will see why. So let us first look at this summation. Let's write down the terms here. Okay, the first few terms. So if I start with j equal 1, this will be, the first term is 2 over 3, صح? So this is 2 over 3 plus 2 over 4 plus 2 over 5, because every time I'm increasing the value of j by 1 until I reach the last one. So let's write the last one and the one before it. So the last one is 2 over n minus 1 plus 2. So what is n minus 1 plus 2? It's n plus 1. So this means that the one before it is 2 over n, right? Fine. So this is the first summation. Now let's look at the second summation. So I'm going to say minus, and let me put the second summation in brackets. 1 over j plus 1, starting from j equal 1. So this will be 1/2, right? Plus, since I already have the minus, so I can just write pluses here. So 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 all the way. Again, let me write the last two terms. So the last term is 1 over n minus 1 plus 1 is n. So 1 over n, so plus 1 over n minus 1 plus 1 over n plus 1 over n. Okay, so now look at the summation. Do you notice that there are things that cancel out? Like, for example, we have 2/3. 2/3 minus 1/3 is what? Is 1/3, huh? So this is 1/3 plus 2/4 minus 1/4. This is 1/4. 2/5 minus 1 over 5. This is 1 over 5. And I'll continue until I reach the last one, which is 2 over n minus, this is the last one, 1 over n. See, that's why I put the last two, because I don't know where am I going to stop. So as you can see, this is the last thing that we did. 2 over n minus 1 over n plus 1 over n. Okay, plus 1 over n. طيب. Now look at this. This looks like the harmonic series, but it's missing two terms. ايش هم التو terms؟ اللي هو 1 over 1 plus 1 over 2. صح؟ 1 over 1 plus 1 over 1 over 2. So let's add these two terms. Okay, so 1 over 1 plus 1 over 2 plus. Okay, so I added these two terms and let me subtract them. Minus 1 over 1 minus 1 over 2. The two terms that I have added, I have subtracted. Okay, fine. Okay, so okay, so now I'm done with this. So what are the terms that have not been included here? So now all the terms down below, no. Well, since we started from 1/3, right? So this means that I have negative 1 over 2, which has not been accounted for. Negative 1 over 2, which has not been accounted for. So let me add this negative 1 over 2. Okay? Because I started with 1 over 3, صح? 2 over 3 minus 1 over 3, 2 over 4 minus 1 over 4. So 1/2 minus 1/2, I need to bring the minus 1/2. But what else? What else? All these have been included. All these have been included until 2 over n, صح? So what is left is plus 2 over n plus 1. So let me add plus 2 over n plus 1. Plus 2 over n plus 1. Okay, so basically these two things are equal, and therefore what do I have? I have this is equal to sigma 1 over j from j equals 1 to n, right? Type minus 1 minus half minus half. This is minus 2, صح? Plus 2 over n plus 1 minus 2, and like this, right? So I have the summation of 1 over j from j equal 1 to n plus 2 over n plus 1 minus 2. So now I need to evaluate. Now I need to evaluate this summation. So I'm out of papers. So let me add. Let me add one more slide. Okay. So let's do it this way. So I will say, can I say copy? And then paste. Okay, it pasted it here. So let me bring this here. Yes. So let's come here. And let's go and actually, let me remove this whole thing. Cut. Okay, now we're ready. Okay. Right. Okay. So this is, by the way, this is what? This is sigma j over j plus 1 times j plus 2 from j equal 1 to n minus 1. Now, this is the harmonic series, sigma 1 over j from j equal 1 to n. What is this equal to? Well, this is approximately the natural log of n, right? And since we are doing the analysis asymptotically, we can do that. So this is basically approximately, oops, I don't want to use another color. So this is approximately len n plus. Now, what is the value of 2 over n plus 1 minus 2? Well, when n is equal to 1, this is minus 1, صح? When n is equal to 2, this is 2/3 minus 2. So it's a little bit more than minus 1. Until when n goes to infinity, 2 over infinity is 0. 0 minus 2, this is basically minus 2, right? So whatever it is something which is between 0 and minus 2, right? It's a number between 0. So I can say that this is, well, instead of plus, let's put it as minus because it is negative. So this is basically negative some big theta of 1, some constant. This is negative theta of 1, some constant. So this is sigma j over j plus 1 times j plus 2. طيب, احنا what did we have? we have twice the sigma. Okay, so dn is equal twice of the summation, right? So let's rewrite it. So therefore, dn is equal to twice of what? Of len n minus big theta of 1. And of course, 2 multiplied by a constant is again a constant. So this is twice len n minus big theta of twice len n minus big theta of 1. And we know that len n is log n, log to the base 2n divided by log e, right? So this is basically twice log n over log e minus big theta of 1, right? We're done. That's it. So now I have the solution. dn is twice log n over log e minus theta 1. Now, what do I want? And I want cn, صح? I want cn. Now, what is cn? Well, dn was cn divided by n plus 1. It's basically this recurrence here. So I just need to multiply the value that I got for dn by n plus 1 to get cn, right? So therefore, c of n is going to be equal to n plus 1 multiplied by twice log n over log e minus big theta of 1. Okay. Now, 2 over log e is a constant. N log n plus log n minus some constant. So this is big theta of what, ya shabab? This is big theta of n log n, which is very interesting. The average case behavior of the quicksort is, in fact, equal to the best case, which is n log n. And the good news is that the constant behind the n log n, or the multiplicative constant by n log n, is actually small. It's not that big, right? It is small. By the way, this is unlike selection algorithm. The multiplicative constant behind the n is actually a little bit large. Okay, is actually a little bit large. So with this, we are done with the average case analysis of quicksort. As you can see, احنا in class we stopped here, right? In class we stopped here, and all what we did now was just show you my mathematical muscles, right? We just did some math, and we came up using the expansion. We came up with this summation, and then with the method that I will ask you, inshallah, about where have you seen this before tomorrow, we were able to solve it nicely and get this value. By the way, the value here seems different from the book. Actually, it's exactly the same. And I will leave it for you to convince yourself. But it is exactly the same. The summation is a little bit different, but it's exactly the same summation as the summation in your book. And the final answer is also exactly the same as the one in your book. So inshallah, we'll see you in other nice videos like this. Assalamu alaikum.